Hello everyone, welcome to my channel. I am PRABHUREDDY, studying in Sri Venkateswara College of Engineering, Bengaluru. Today's subject is Mathematics. Subject code is BMATE101. The first topic that we will be covering today is Maclaurin series expansion. The expression of Maclaurin series is y of x equals y of 0 plus x divided by 1 factorial into y1 of 0. y1 of 0 represents the first derivative of y of x plus and so on it continues. Let's see a problem based on Maclaurin series for understanding how to do the problems and substitute in the following equation. First we have to write the Maclaurin series expansion for expression. Then consider y is equal to the given equation. Here the given equation is sin x, so we have to consider y equals sin x. Then find out y1, that is first order differentiation of sin x. y1 is cos x. y1 of 0 is cos 0, that is 1. And then y2 cos x differentiation minus sin x, and y2 of 0 is minus sin 0 is equals to 0. As follows, you have to find out y3 value, y3 of 0, y4, y5, y6 values, and their consequent y4 of 0, y5 of 0 and y6 of 0 values, and substitute in the Maclaurin series expression. Then we will get sin x equals 0, y of 0 is 0, y1 of 0 is 1, so x divided by 1 factorial into 1 plus x square divided by 2 factorial into 0. 0 is nothing but y2 of 0's value, x plus x3 of 3 factorial into minus 1 plus x to the power 4 divided by 4 factorial into 0 plus x to the power 5 plus 5 factorial into 1 plus x to the power 6 divided by 6 factorial into 0. So the final answer by simplifying this comes is sin x equals x divided by 1 minus x to the power 3 by 3 factorial plus x to the power 5 by 5 factorial minus x to the power 7 upon 7 factorial, and as on. The next problem, let's see. Expand e to the power x up to the term containing x to the power 6 using Maclaurin series. Here it is given that we have to expand e to the power x up until sixth derivatives, that is x to the power 6. First we have to consider y equals e to the power x, and then we have to find out y1 of x, y2 of x, y3 of x, y4, y5 and y6, and their subsequent y1 of 0, y2 0, y3 0, y4 0, y5 of 0 and y6 of 0 values, and then substitute them in the Maclaurin series expression. So we get, after substituting, is e to the power equals 1 plus x upon 1 factorial into 1 plus x to the power 2 upon 2 factorial into 1 plus x to the power 3 divided by 3 factorial into 1 plus x to the power 4 divided by 4 factorial into 1 x to the power 5 plus x to the power 5 divided by 5 factorial into 1 plus x to the power 6 divided by 6 factorial into 1, and then by simplifying we get e to the power x equals 1 plus x to the power 2 divided by 2 factorial, x to the power 3 divided by 3 factorial, plus x to the power 4 divided by 4 factorial plus x to the power 5 divided by 5 factorial plus x to the power 6 divided by 6 factorials. You can also simplify the factorial form and write the numerical values exactly. The next question is, expand root of 1 plus sine 2x up to the term containing fourth x to the power 4 using Maclaurin series expansion. Here we have to find four derivatives, up to fourth order derivatives. So first consider y equals root of 1 plus sine 2x. 1 can be written as sine square x plus cos square x by trigonometric identities. Then after considering 1 equals sine square x plus cos square x, we get the form as y equals root of sine square x plus cos square x plus 2 sin x cos x. Then by simplifying we get y equals sin x cos x. We have to find the y1, y2, y3, y4 values and the consequent y1 of 0, y2 of 0, y3 of 0 and y4 of 0 values. Then after substituting in Maclaurin expansion we get y of x equals that is sin x plus cos x equals 1 plus x divided by 1 factorial minus x to the power 2 divided by 2 factorial minus x to the power 3 divided by 3 factorial plus x to the power 4 divided by 4 factorial. The next topic is indeterminate form and how we solve using L'Hospital rule. Let's see what is indeterminate form. In evaluation of a limit, we obtain the forms like 0 by 0, infinity by infinity, infinity minus infinity, 0 into infinity, 0 to the power 0, infinity to the power 0, 1 to the power infinity, which are not defined in mathematics. So they are called as indeterminate forms. When these forms occur, we can use L'Hospital's rule to solve this type of problems. So L'Hospital rule is, if f of x and g of x are any two functions with limit x to limit f of x tends to a equals 0 and limit g of x tends to a equals 0, then limit limit x tends to 0 f of x divided by g of x equals its derivative. And then if the form is again not defined, that is infinity by infinity or 0 by 0, again you have to differentiate, that is f double dash of x divided by g double dash of x and so on. Let's see a problem on indeterminate form solving. The first problem is, limit x tends to 1, x square minus 4x plus 3 divided by x square minus 3x plus 2. First we have to assume it is equal to k. K equals limit x tends to 1, x square minus 4x plus 3 divided by x square minus 3x plus 2. By applying LH rule, that is L'Hospital rule, what we get is k equals limit of 2x minus 4 divided by 2x minus 3. Here 2x is derivative of x square and 4 and 3 are derivatives of 4x and 3x respectively. By solving the form, what we get is, and applying limit, what we get is minus 2 divided by minus 1, that is plus 2. So this is how we can solve a problem using L'Hospital rule of a indeterminate form. Let's see some more questions. Limit x tends to 0, x into e to the power x minus log into 1 plus x divided by x square. Uh, k, let's consider is equals to k. After considering it is equal to k, we have to apply LH rule and differentiate it. Then we get k equals limit extends to 0. We apply product rule to x into e to the power x. We get x into e to the power x plus e to the power x into 1 minus differentiation of log into 1 plus x is minus of 1 divided by 1 plus x whole divided by 2x, that is differentiation of x square. Again it is of the form of 0 by 0 after applying the limits. So we again apply LH rule, that is L hospital rule. Then we get k value as 3 divided by 2. You can see the steps in the slide. The next problem is evaluate limit x tends to pi by 2 sin x to the power tan x. In this case, first we have to assume it is equal to x, and then we have to take log on both the sides. After taking log, we get log k equals log of limit x tends to pi by 2 into sin of x raised to power tan x. After that we get, after simplification of log function, tan x is a power and it can be written to the left side of the log. Then tan x is written as 1 by cot x. We get log k equals limit x tends to pi by 2 log sin x divided by cot x, which is of the form 0 by 0. So we apply L Hospital's rule. Log k equals limit x tends to pi by 2 1 divided by sin x into cos x whole divided by minus cos x square x. And after simplifying the numerator and denominator, we get in the RHS limit x tends to pi by 2 minus cos x into sin x. After applying the limits x tends to pi by 2, we get log k equals 0. Log on shifting to right hand sides become antilog. K equals e to the power 0, and we know that anything to the power 0 is 1. So finally we get the answer as k equals 1. Thank you everyone for watching this video. If you find this video interesting and knowledgeful, please like and share the video and subscribe to my channel. Thank you everyone once again.